Hello, everybody. So my name is Michael Ooms. I will first make a and quick introduction on Intertek, and then develop the work we have done for ADEME on the development of the database. So Intertek is first of all, it's new for me because previously I used to work for SMEs called RDC Environment, but Intertek acquires us 6 months ago. So now we are part of the Intertek group, well known in testing, inspection, certification, and auditing activities. So it's a group for 30,000 people present in more than 100 countries and with a capacity of testing and auditing thanks to more than 1,000 laboratories all over the world. So within Intertek, I'm in charge of the Center of Expertise called Intertek RDC. This Center of Expertise is focusing on life cycle assessment and carbon footprint calculation. It's now more than 50 people, mainly in Europe, but also in US and in China. And we can work closely with the global network of the more than 100 environmental auditors present in 20 countries from Intertek. I'm personally involved in a lot of methodological framework development like the ISO, the PIS, BPX 30323. And I will speak more deeply about the development of the French LCA database and the link with this database and tools in order to scale up and to develop the carbon footprint of massive products. So our basic services are structured in 3 types: sustainability product services, sustainability organization services, and all services about auditing and verification of data on site. So let's talk now about the French LCA database. So the structure well known is the ADEME AFNOR platform. Yeah, it's here. It was previously structured in 3 parts. So the methodological working group that has published the BPX 30323 guidelines that covered all different product categories. Then you have several product categories groups with the objective of developing PCR. And there was one working group working on communication, but this was taken by the French ministry. All the things about the communication is driving now by the French ministry. Two new working groups. One is called the Database Committee, and the other ones, and there are several different technical committees. And the objective of those working groups is to define which data shall be in the further French public LCA database. So the objective is clearly to define the needs and which data shall be in the further database. So the goal of the French LCA database is clearly to support environmental labeling for consumer goods by providing generic LCA data. It's important to understand that the goal of the French government is not to develop a new Ecoinvent or a new full LCA database. The objective of the French government is to provide data only useful to calculate the environmental footprint of product categories for which PCR are existing. And this is really important. So it's a co-construction with different stakeholders through technical committees. So the principle is that you have the general BPX 30323 guidelines. You have then the different PCRs, and within those PCR, they will define which are the specific, semi-specific, and secondary data. So I will just show you here. So the principle is that each sectorial working group, if I click here, will define a PCR based on pilot project which carry out complete LCA. The objective is define the main environmental impacts, for example, the 3 rounds presented for food, biodiversity, water footprint, and climate change. The main parameters that influence the LCA results, and this is directly linked with our work for the development of the French database, because those parameters are classified into mandatory parameters and optional parameters. So by experience, when you perform a LCA, the key parameters that lead to a differentiation for the environmental footprint between 2 products are between 10 and maximum 20 parameters. So the differentiation is only due to those 10 or 20 parameters. And those parameters will be classified as mandatory, as specific parameters. And our work, by the development of the LCA database, is to provide LCIA, or emission factor, let's call it emission factor, linked with those 10 or 20 key parameters. I will just give you an example on how it works. So this is an example of a process tree for LCA. So you start, So you start from the functional unit, and then you define which processes are involved to fulfill your functional units. So here you have your system boundary. It's a very small part of your LCA model. And then each cases here are so-called emission factor and are provided and will be provided by the French databases. But it's important to know, for example, let's take an example of a textile product. If the PCR, if the PCR mentioned that it's important to distinguish cotton from India, cotton from Thailand, cotton from China, and cotton from USA, the PCR say it's a mandatory parameter to say where the cotton is coming from. If we have no specific emission factor for cotton from India, cotton from Thailand, cotton from Pakistan, and so on, then we have a problem. And this is typically the work we are doing with ADEME to see what are the available LCIA or emission factor and which will be put into the French database, and what are the mandatory parameters asked by the PCR. And sometimes it matches and sometimes it doesn't match. So this is the basic concept. So if I take here the example, if I say, for example, let's take a tomato, it's important to distinguish Spanish tomato from French tomato. If we don't have an emission factor for those type of tomato, we cannot do this. Another goal of the technical committees is to describing the data need, but as well as the management and the quality requirement. So we will also give recommendation and clear requirement on the minimum data quality that the data shall meet. So the content of the LCA database will be two things: processes with reference flow, list of elementary flow, list of impact categories, and some background data, so-called metadata. But only LCIA results will be available. That means that you will, for example, for carbon footprint, will have CO2 equivalent emission, but you will not have the split between methane, N2O, CO2, and so on. So what will be available is only LCIA results. The characterization factor that we will use to go from elementary flow to LCIA result will be those provided by the GRC ISPRA. So that's the structure of the LCA database. So you have process. ADEME will have access to the inventory, so to the elementary flow, but the public and the companies will only have access to the results, so to the LCIA. And they will also have access to some background data, the sources, the geographic coverage, the technological representativeness, and so on. So where are the data coming from? That's really an important question. So there are three canals and three sources. The first one and the main one is that we will import existing data coming from existing databases such ELCD, GABI, Ecoinvent, database provided by federation, like for example Plastic Europe's, World Steel's, EA, and so on. So I would say that 60% of or 70% of the data will come from those sources. And thanks to the technical committees, we will define which data we need from those sources, and there will be some subsequent contracts between ADEME and each data provider in order to import those data into the French LCA database. So the second canal, which is also an important one, is that some data will be directly produced. So there will be a production of new LCIA data This is typically for food for food industry, because we identified that there is a lake of data coming from those sources. So ADEME, with the French ministry, decided to develop some specific data. This is the so-called Agribalis project. And the last one, which is also very interesting for industry, for company will have the possibility to provide their own data. So if I am a company and I've developed a specific product, I make a LCA, I provide the data in the ELCD format, I go through the database committee governance, and if I fulfilled the quality requirement, ADEME will import my data as a company into the public database. And there is ongoing discussion about the confidentiality of the data, because if I am a company, I can ask that those data are confidential for 1 year, 2 years, 2 or 3 years. It's still under discussion. So the format of the LCA database is based on the ELCD format. So it's not the eCospol format, it's the ELCD format. It's the reason are describing here. What is important to notice is that the French LCA database is not a dynamic database. That means that because you know that, for example, let's take the example of emission factor of tomatoes. In fact, it's in itself a small LCA. It depends on the emission factors of the electricity production, of the pesticide production, of the transport, and so on. So the French database will not be dynamic. That means that if the emission factor of pesticide is modified, the emission factor for tomato will not be automatically adapted also. We will have to ask an update of the tomato factors to the data providers. It's not the best solution, but it's the more practical solution. About the quality, so each data shall be qualified for geographically, time-based, and technological representativeness, and an evaluation of the quality will be given by the provider, as well as a review of the data. So the data quality requirement will be different for providers, for data coming from Ecoinvent, GABI, and so on, recognized LCA database, than for companies who want to provide data to the French database. So the management of the database, we foresee an update every 3 years if sectorial if needs appear, or in case of structural evaluation, methodologic, or electricity process. Once we integrate the data into the French database, there are automatic rules to check the representativeness and the quality of the data. And what is also important is that ADEME will also provide default dataset in order to fill in the gaps. Let's take again the example of the tomato. If, for example, we don't have an emission factor for the tomato, ADEME will create a default value based on the worst case scenario. They will take, for example, the worst emission factors from fruit, for example, and say to the company, we don't have this emission factor up to now, so we suggest that you use this worst case scenario in order to give an incentive to provide this missing emission factor. So the timeline, maybe take it here. So the idea is that a first release of the database will be available on July this year, 2012. With processes on electricity, transport, litter, and some main materials, plastic, steel, aluminum materials, and manufacturing. And then we will add more and more data in order that all data needed for the calculation for validated PCR are available. So the idea is first released in July, and then in first 2013 we will have the last version. Last thing is the link between the database and the tools, because for the harmonization you need PCR, common methodological rules, you need common LCA data, and you need the same way of calculation, and that can be provided through tools. This is an example of a tools we have developed for packaging industry. So you see that the principle is that you can open a study, so create a new project, create a new project, select the product category you want to work on. So for example, let's take a PET bottle, define this case. And then within the tool, you have 3 parts. Here you see the product you are modeling. Here you see the section where you can put your specific data. So the data that you have to fill in here are the primary data or the semi-specific data. And here you have automatically the results. So you have the different life cycle stages here. And then, for example, you say, for bottle, it's important to fill in the weight of the bottle and, for example, the cap, and to mention if the cap is in HDP on PP and the weight of it. So you fill in all your specific and semi-specific data here, and you have automatically the results below, absolute value, or in different charts. And what we have also recently developed, thanks to this tool, because the problem is that up to now you have, as you know, several standards, is within the tool you can select which standards or PCR you want to follow. You can see here the BPX, the PS, GHG protocol, ISO 14067, ILCD handbook, product environmental footprint, the sectorial guidelines BEER, and once you select a standard, the key methodological rules are automatically adapted. You can see here an example for recycling allocation, for energy modeling. Do we take into account or not the concept of delayed emission or not? And the user of the tool, so it's automatically adapt, but the user of the tool can change it if he wants to change it. So that's the link between database and the tool. Thanks for your attention.